The essential questions for the stoichiometry unit are: how do stoichiometric ratios relate reactants and products in a chemical reaction? How are stoichiometric ratios used to predict the amounts of reactants and/or products? And how can dimensional analysis or unit analysis be used to express stoichiometric ratios? By the end of this video, you should be able to write stoichiometric ratios and use these stoichiometric ratios to convert from moles of one substance to moles of another, given the balanced chemical equation. Our first question is, how many moles of hydrogen are required to completely react with 2 moles of nitrogen? And it gives us the balanced chemical equation of 1 mole of nitrogen gas plus 3 moles of hydrogen gas form 2 moles of NH3. Now, we are going to be using unit analysis or dimensional analysis to be solving these problems. And I know that for every 1 mole of nitrogen, I need 3 moles of hydrogen. So, in order to do this unit analysis, we're going to start with the thing that is given to us. And that is, I know that I am using 2 moles of N2. So for these, you need to not only write the units, but also what substance it is you're dealing with, because you are going to be dealing with multiple substances. We're trying to go from moles of nitrogen to moles of hydrogen. I am not going to be using anything else. Any stoichiometric conversions, we're only going to be using 2 substances at a time. In this case, the nitrogen and the hydrogen. Every other portion of the chemical equation can be ignored. It's just there to tell you that's what reaction is taking place so that we can use the coefficients. So I'm going to do parentheses and my line. It's only going to take me 1 step to do this equation. I know that the chemical equation has 1 mole of nitrogen. Because I'm starting with moles of nitrogen, in order to get the moles of nitrogen to cancel out, the 1 mole of nitrogen must go on the bottom. And what I'm trying to find, moles of hydrogen, is going to go on the top. The mole-mole ratio from the balanced chemical equation is going to be using the coefficients. 3 moles of H2 and 1 mole of N2. Notice mole of N2 on the top cancels with mole of N2 on the bottom, and I'm left with moles of H2, which is what I'm looking for. When you plug this into your calculator, or this one's easy enough for mental math, 2 times 3 divided by 1 gives me 6. 1 significant figure, I still have 6, and the units are moles of H2. Now, it doesn't matter whether you're given reactants or products. For these problems, it does not matter which side of the arrow the different substances you're dealing with are on. So our next problem, we're using the same chemical equation, but this one says how many moles of NH3 will be produced when 5 moles of N2 reacts with an excess of H2. Now this question is addressing every substance in the equation. However, it's asking me for how many moles of NH3. So I know that I'm looking for NH3, and it tells me how much N2 I'm starting with. So those are the 2 substances I'm going to be dealing with. When it says with an excess of H2, that's stated to tell you that this is the reaction that's taking place and that there's enough H2 that all of the nitrogen will actually react. It is not going to play any part in your calculation. So we're going to start with what we actually have, which is 5 moles of N2. So again, that goes out front. And then my parentheses and a line. Since I have moles of N2, I know I need to put moles of N2 on the bottom and that is going to go in the bottom with its subscript, which is 1. And what I'm trying to find, moles of NH3, is going to go on the top with its subscript. So 2 moles of NH3 on the top. Moles of N2 on the top cancel with moles of N2 on the bottom, and I'm left with moles of NH3, which is what I'm looking for. And then plugging in, I have 5 times 2 divided by 1 gives me 10. Notice that this time I had 5.0, which has 2 significant figures. Now the coefficients are just whole numbers, but they have to be whole numbers. So even though it's written as 2, I know that that is exactly 2 because you can't have decimals for coefficients. So these 2 numbers, your coefficients will never affect your significant figures. So the 5.0 tells me that I need 2 significant figures in my answer, so 10 with a decimal point, and that's how many moles of NH3 I have. So remember, whatever you start with, whatever is given to you in the problem is what goes out in front with the number that the problem tells you you have. A mole-to-mole conversion will just be one step. Whichever substance you started with must go on the bottom so that it cancels out, and it's going to go on the bottom with its coefficient from the chemical equation. The thing that you're trying to find is going to go on the top with its coefficient from the chemical equation. Everything that you do is only going to be dealing with 2 substances. You can ignore everything else that is part of that chemical equation.